Hey learners, Jared here, and if I asked you to explain the Doppler effect, I would imagine that most people would respond with, "Eom." But what does that actually mean? What is physically happening to cause the sound to give you that pew effect? That's what we're going to look into today. What is the Doppler effect? We're going to start our discussion of the Doppler effect with sound, specifically the relative velocity of a sound source with respect to an observer. Now, relative velocity means that either the sound source is moving, or you can imagine that the observer is moving. In both cases, to the observer, it looks like that sound source is moving. Now, you've probably experienced this with a police or ambulance siren, or maybe a really fast car that gave you a honk, you know the type, or NASCAR as they drive by. Something like that gives you that effect that we're going to look into. Why does that occur? So if you think about sound waves and how often they crash into your ear, that is the frequency of the sound. The more crashes into your ear that occur, the higher the frequency, the less crashes, the lower the frequency. And so to think about this, waves crashing into your ear, let's take this and move to the ocean, standing still as the waves are crashing into you. If you are standing still, then the waves crash into you at a certain frequency. If you start to move toward the waves, that is, you move against the waves' motion, then waves will crash into you more frequently. And the faster you move, the more waves will crash into you per unit time. Nothing has changed about the speed of the waves or how far apart the waves are, anything like that. The only thing that's changed is now you are moving with respect to the waves. So more waves crashing into you is kind of like more sound waves crashing into your ear. The higher frequency is going to occur. This happens when you move towards a sound source or a sound source moves towards you. Those waves are going to crash into you more frequently if you move toward that sound source. The medium that the wave is traveling through is determining the velocity of the actual waves. Nothing can change that with respect to the waves. The medium is what determines that. As you move towards a sound source, you are going to hit sound waves more frequently than you would if you were standing still. No different than just standing in an ocean. Now, when the sound source is moving towards you, nothing changes about what you hear, but the dynamics of it are a little different. Every time the sound source emits a wave, well, now the sound source moves forward a little bit and emits another wave, and another wave, and another wave, and another wave. And those waves kind of bunch up in the front of that object as it's moving towards you. The closer those waves are together, the higher the frequency is going to be, because again, their velocity isn't changing. So the closer those waves are, their wavelength goes down, which means their frequency goes up, which is why you hear a higher pitch, a higher sound. Now, moving away from a sound source or having a sound source move away from you would be like standing in an ocean and then heading towards the shore. You would hit waves less frequently because now you are moving with the waves. If you moved as fast as the waves, then you wouldn't have any waves crash into you. This is similar to moving away from a sound source. You aren't going to run into as many sound waves because you're now traveling with those sound waves. Less frequency means lower note. So that's why as an object or sound source travels towards you, you have the high note, but then as it travels past you, you have the low note. Thank you guys so much for watching. I hope that gives you kind of a ballpark of what the Doppler effect is. I will see you here next time, and as always, keep learning.